Welcome back to People Analytics and Excel Employee Attrition. Today I am excited to move on finally to the modeling step in the awesome framework. So in the previous video, which was a long one, we spent an hour scrubbing and exploring our data. We got everything ready to go, and now that we finally have our data set prepared, we're going to do the exciting and the technical part, and we're going to model that data so that in the final step, the interpret step, we can get some insights out of it and start driving business decisions. All right. So I'm gonna pull up my data set here, and I just want you to notice. So in the previous video, I made the point at the end there. That thing would have gone on probably for another 15 to 20 minutes if I had actually completely finished the job, and I didn't want to take forever because I'd already been working on it for quite a while. So I talked through at the end just that I'd finish encoding the variables and all that kind of good stuff before we came here. So I just want to show you that's been done. If I come and I show you everything I've got here, you can see I've got everything's been encoded. I don't have any text values in here at all anymore. All right, so we're pretty much ready to go at this point. All right, so I've got the add-ins tab selected. I've got real statistics here, and as I mentioned earlier, in order to do a logistic regression using the real statistics add-in, I just come here, I click on the down arrow on real statistics, select data analysis tools, come to reg, which is all my regression tools, and I select binary logistic and probit regression. We're doing binary logistic regression here. I'm going to select OK. Okay, so I have a data set, and I've gotten everything into a numeric format, and I've identified and taken care of some issues already. And now it's real tempting to say, all right, I'm good to go. It's time to take this data, I'm going to push it into this model, and I'm going to see what comes out the other side. Right? So easy way to do that. I've opened up my menu here. I've got input range selected. I'm going to select my first value here, my upper left value. I'm going to hold down the Control and Shift key, down arrow to get to the bottom and select the first column, right key to select the remainder of my data set. In order for this to work, I have to have find my cursor here. I come to the top. I have to have my dependent variable, or the thing that I'm trying to predict or regress on, here on the right side. So my rightmost variable here is my left feature, which is a 1 if the employee left, a 0 if they stayed. All right, so I've got my data set. It does include the headings, as you can see here, so I want column headings to be included. That's checked. I do want to see the summary. I'm doing a logistic regression with the raw data using Newton's method. I've got the conventional 0.05 cutoff level for significance here. Basically, that's my threshold. Any p-value less than 0.05, I'm going to declare arbitrarily to be statistically significant as a predictor of attrition. My classification cutoff here is 0.5. That means that any value below that will indicate that the employee left, and any value above that will indicate that they stayed. Or excuse me, it's the other way around. Any value below 0.5 will indicate that they stayed. Any value above 0.5 will indicate that they left. Right? So that's how the algorithm will know whether to decide an employee left or stayed based on the output of the regression. I'm going to change this to 35 iterations for Newton's method, just because the other software that I use frequently uses 35 iterations. I just like to keep for Newton's method, and I just like to keep things standard across the two. I'm going to delete the value here in output range because I want it to create a new sheet. All right, so now that I've done all that, I can just hit OK, and I'm going to get the result. Now, I'm not actually going to hit OK. I'm just going to X out of here because I've already run this model, right? So I'm going to show you what the output was. So I've got my results here, and this is what the results look like, right? So it's going to show me the data set again. It's going to show me this here, this ROC curve, the receiver operating characteristic curve. And basically, a good receiver operating characteristic curve will rise sharply towards the top left corner and then come across the top here. So a perfect ROC curve would come up, pretty much kiss the corner here, and then come right across. A bad one will do exactly what this is doing, which is just rise at diagonal across the graph. What this ROC curve is telling me is that this model effectively has no idea what's going on. It's not effectively even giving me any extra information. Now, more importantly, I know I've got a problem here. I just use control down arrow to get to the bottom of my data set. Right, so I'm on the last row here. Below the last row, I've got my coefficients. It calculated 0 for all my coefficients. That is a problem. All right, and then I've got errors for all of Sarah's stuff, for standard error, for the p-value, for the upper and lower bounds of my 95% confidence intervals. I basically didn't get a value at all. That's a problem. All right, basically, it's pretty obvious that the algorithm failed to actually arrive at a solution. All right, so just looking at this, I know that this is garbage, right? And what Excel does not tell you when you use real statistics is why. So I know from running the same regression in a different piece of software that I have a singular matrix here, high collinearity among my variables. Now, I don't expect you to know what that means. We'll talk about it a little bit here in a second. But basically, the bottom line is this algorithm failed. All right, I'm going to delete this result. It's useless. All right, now I can also run this same method, or this same, excuse me, can't think, the same logistic regression using solver, right? So I'd input all the same values here and then click solver. Now, what happens when I use solver is that real statistics calculates the coefficients by brute force using the solver, which is a set of optimization tools here, and it comes up with an answer. Now, when you run it, because it's taking that brute force approach, it takes about 10 minutes or so on this data set to arrive at an answer. When I do arrive at an answer, it looks like this. All right, so my receiver operating characteristic curve does bend upward. That's a good sign. But again, when I come down here, okay, so I just use control down arrow to get to the bottom. When I come down here and I look at my coefficients, I do have coefficients now, and that's a really good thing, and I'm glad I have coefficients, but I have no standard errors. I've got no upper and lower bounds for my confidence intervals. So it's hard for me to, and I have no p-value, so I can't tell what's statistically significant. So that makes it a little harder for me to interpret and actually use this output for any actual problem. Right? I want and I rely a lot on my confidence intervals and my p-values in order to kind of interpret and talk about my results when I'm presenting this kind of stuff to decision makers, when I do this kind of analysis. All right, so I'm going to delete this too. So we have a serious problem here. Just using the data the way we have it set up, we cannot arrive at an actual useful output. All right, so basically, here's the problem that we have. We have features or variables, columns. We have columns in this data set that are effectively linear combinations of other columns. So let's say, just hypothetically, let's say that this column here was equal to this column plus this column. So this is 2, this is 1, this is 3, this is 4, this is 1, this is 2, so on and so forth. What that means is that this column here basically is just a combination of the other two columns, and not only does it not add any additional value to the data set, but it actually causes it to be singular, which I'm not going to explain what that means, but the bottom line is that it makes it impossible for our algorithms to converge. It makes it impossible for us to do regression, to do this kind of regression. So what we need to do is we need to be able to identify where the problems are, which columns in this data set are causing us this issue. And fortunately, we are equipped to answer that question because we have real statistics, and it provides us with a tool, a function called VIF, for variance inflation factor, or VIF, that allows us to calculate a variance inflation factor for each column. And the higher that number is, the more likely it is that that's one of our collinear variables, our issue, our problem columns, if you will. Okay, so here's what we're going to do. I'm going to show you a real easy way of going through this and solving this problem. So first thing I'm going to do is I'm going to come up here to View, Freeze Panes, and I'm going to freeze the top row because I'm going to do a lot of my work at the bottom of the sheet below the data set, and I want to be able to see what my column names are while I'm at the bottom there. So now you'll notice when I scroll down, notice I'm scrolling down, but it's keeping that top row there so that I can still see. Super helpful. All right, so I'm going to come all the way down here to the bottom, so I'm just going to click into it. I'm going to hold down Control down arrow, so that brings me down to the bottom. All right, I'm going to insert a column here that I can use to type in some stuff. All right. So I'm going to come down here to row 1475, and I'm going to type column name and VIF. Actually, I'm going to spell it out. Variance inflation factor. Now, in order to make this work, I need to number my columns from 1 to n. I have 41 columns in this data set right now, not counting the one that I'm trying to predict. So I need to know which column is this. Now, the easiest way to do this is I could just type in 1, tab, 2, tab, 3, right? And as I go, then I select a few of them, I drag my fill handle, and I drag across, and it numbers them. The problem with that is that if I then delete a column, it'll skip from 4 to 6, and these numbers will never change. So I need to use a function to do this so that as I'm deleting columns to fix my variance inflation and get rid of the collinearity in this data set, I don't have that problem. I don't have to keep coming in here and redoing the numbers. All right, so I'm going to use the match formula. So I'm going to type in equals match. I'm going to use the tab key to open up my brackets. All right, my lookup value is going to be the column name that's directly above the first value in this column, comma, and now I need to define my lookup array. My lookup array is going to be all of these column names. So I'm just going to click here on age, and I'm going to drag across. I could also use Control Shift right arrow if I want to, but I'm not going to. All right, so I've selected that, comma, and now my last option here is whether I want an exact match or not, and I always want an exact match when I use match, pretty much. So I'm going to type 0, close the parentheses, enter, and now when I come here and look at it, I can see that that's 1. Now, one other thing I want to do, if I drag this straight across, so I want you to notice I've got B1 is age, B1 to AP1 is all of my column names. I want this to change when I drag this across, but I don't want this to change, right? I want to know where daily rate is still in this same list of names. But if I drag this across using a fill handle, you'll notice that it dragged the whole thing across, and now it's starting at C1 and going past the end of the data set. So I don't want that. That's not good. All right, so I'm going to come up here. I'm going to highlight this. I'm going to hold down my Windows key and press F4. I have to hold down the Windows key for this particular machine. Some Windows machines, you just hit F4, and it'll get the job done for you. But it puts all these dollar signs in here, and that keeps this stable now. So when I drag it across, this value will change. These values will not. Very helpful. Hit enter. Now I'm going to drag it across. And you'll notice for all of these, I've got the same thing, right? So now this is going to remain consistent all the way across, and I'm just going to go ahead and drag this all the way across to, years with, whatever this is here. Hit enter. All right, I don't need it for this because I'm not going to calculate the variance inflation factor for the column that I'm regressing against. All right, so now for column name, super easy. I just hit enter, or excuse me, I press equals, and then the column name, and I hit enter, and there you go. It just brings that value down there, so I'm going to come across, do the same thing. I would like it to be centered, so I'm going to go to home. I'm going to press center. I'd also like for all of these to be readable, so I'm going to select all of these columns, and I'm going to double click here on the boundary between them, and that'll right size them so that I can see everything. And now I'm going to calculate my variance inflation factor. Pretty easy to do. I'm going to use equal, type in VIF, tab to open up the parentheses, and now I've got the VIF function, the variance inflation factor function that comes with my real statistics. All right. And actually, before I do this, I want to do one other thing. So I'm going to hit escape. This is something I'd like to show you. All right. So I'm going to click into my data set. I'm going to use Control up arrow to come up to the top, and it's going to refuse to work for reasons I don't understand. All right. I'm just going to drag it up. All right. So here's what I want to do. I want to create a named range for all of my data so that I don't have to select it every time I do this, and so that when I reference it, I don't have to worry about it changing from cell to cell. All right, so the easy way to do that, and this is pretty nifty, right? I'm going to hold down Control Shift. I'm going to come down. So now I've got all my data. I'm going to come across. I'm going to let go of Control, hold down Shift, and come back left one, so I can unselect my dependent variable here. And I'm going to come up here where it says B2, and I'm going to name this my data. I'm just going to name it data. I'm going to hit enter. All right. So now if I want to find that, I can just either hit the F3 key or the Windows F3 key. So if I do that, I get this dialog box that opens, and you can see that that's in here now. What this refers to is that entire range I just selected with all those values. Now what's super helpful about this, I'm just going to hit cancel, is now when I want to reference that for my variance inflation factor function, I no longer have to come up and drag and do all that kind of stuff to select it. I just hit enter, VIF. I'm going to use tab to enter to open the function up. And now what I need is I need my data. So I'm just going to type it in, comma, and then the next argument is going to be this number right here. So I'm just going to select it, close my parentheses, hit enter. And now I'm going to give it a minute, and you can see that it calculated a value. I'm going to expand this a little bit just so you can see. Right, this can be a very long number. In this case, 8 digits or something like that. Anyway, not too worried about that. So now, because of the way I did this, I can just drag this across. So you'll notice here, I've got the same data selected, and now I'm using this value right here instead of this one. All right, so I'm doing it for this column. So now I can just do the same thing. I can drag this all the way across, and this is going to take a minute to work. It's doing quite a bit of work here. It's calculating a variance inflation factor for each column against the entire matrix here, which is fairly large. We have a matrix here with 1,470 rows and 41 columns. That's a good sized matrix. There's a lot of data in this data set, right? So we're going to sit here and let this spin just for a minute, let it think. And I'd just like to make the comment here. What I'm doing right now, this sitting here and watching my computer think and listening to the drive inside it spin faster and faster and hoping that my computer doesn't explode is a pretty typical part of doing analytical modeling. If you have access to high-speed resources, you do your computing on the cloud, it won't be as much of a thing. But for your typical analyst working on a desktop computer or a laptop, this is normal. And even the big fancy algorithms done by the really sophisticated companies like Google, the folks that do those algorithms, they spend a lot of time just sitting and waiting for their computers to think and train their models. So this is a pretty normal thing. I've read quite a few books waiting for models to train. It's just a normal part of life. All right, so now we have a variance inflation factor for all of our columns. All right, so here's something I want to do. I just want to identify any of them that's, let's say, greater than 10. So I'm going to select my first value here. I'm going to hold down Control-Shift, right arrow. That'll select all of them. I'm going to come up to Home, Conditional Formatting, Highlight Cells, Greater Than 10. And I'm just going to go with the default here where it highlights it with a light red fill with dark red text. If I want something else, I could choose it right here, but I'm not worried about it. I'm going to select OK. And now my values that are higher than 10 are going to show up here, right? So lab techs, research scientists, they both show up. The research and development function, that whole department, is a little inflated. All right, so it's interesting. Now I have something else here, though, that I noticed. I have a few values here that couldn't be calculated. Now I can tell you from doing this in a different piece of software, these values are infinitely high. They're so big that they can't be calculated effectively. So we have an immediate, or we have an immediate case right here where we need to get rid of these columns that have this problem, right? So to do that, I'm just going to select the column, right-click, delete. Bye-bye Edfield HR. And then again, I'm going to wait and I'm going to sit and I'm going to let my computer spin and think, because now that I've done it, it has to recalculate all these variance inflation factors. And it takes a little while. Again, this is a pretty normal part of the process. Actually, the hard work, the really intense, often mentally laborious part of analytics is actually everything leading up to this step. The getting the data, cleaning the data, putting it into a shape where it's ready for analysis, imputing missing values, doing all the stuff that you got to do to get ready to actually model. And then once it comes time to model, it's pretty simple. All the algorithms are written for you. It's not like you're coding up a logistic regression or a decision tree or random forest from scratch. You're taking somebody else's excellent, typically open source code, and you're just putting your data into it, waiting for a result to come back. And sometimes that happens really quickly. Sometimes it can take hours, many hours. And you're just sitting and waiting for your computer to think and hoping it doesn't, run out of power and die or something. But this is a normal part of the process. Something worth thinking about. All right, so that's gone now. And I've got 3 more here. So these 3 job roles, sales reps, research directors, and HR, again, they all have the same problem. So I'm going to highlight all of them. Right click. I'm going to make them go away. And again, I'm thinking, you see down here, it's calculating 4 threads. It's thinking about what it wants to do. And then when it's done, the nice thing is, so when it's done, all of these are going to recalculate. All the variance inflation factors will recalculate. Because we set up conditional formatting, that's going to change depending on what the new values that are calculated are. So we don't have to keep coming through and looking and re-highlighting stuff. So that's the beauty of using functions and conditional formatting and that kind of stuff in Excel, is it really saves you a lot of time. Once you set it up, especially if you become proficient to a point where it doesn't take long to do it, it saves you a huge amount of time. So it's well worth it to become highly competent with these things. All right, so this is interesting. All right, so notice that research and development had a variance inflation factor of 14 before. Now it's down to 5. That's pretty reasonable. I like that. And I come across here, I don't see a single variance inflation factor that's out of control anymore. I don't see any issues with this. That's encouraging. All right, so what I'm going to say now is I'm probably ready. I've probably solved my collinearity singular matrix issues. I think I'm ready now to actually do this analysis and come up with a result that I can really use. So I'm going to come up to the Add-ins tab, select Real Statistics, Data Analysis Tools, Regression Models, Binary Logistic and Probate Regression, hit OK. I'm going to select my data using Control-Shift down arrow, right arrow. I do want my column headings to show up. I do want to use my raw data to do logistic regression using Newton's method. I'm going to leave the conventional 0.05 alpha value in there. I'm going to leave my classification cutoff at 0.5. I would like to use 35 iterations for the reasons I mentioned earlier. I'm going to delete the output range because I want it to show up in a new sheet. And I'm going to say that's good. I'm going to hit OK. And once again, I'm going to wait, but not too long, because look at that, we already have results. So we have what looks like a pretty healthy receiver operating characteristic curve here. It's very similar to what we got using Solver. All right, so when we took the brute force approach, but it didn't take 10 minutes to train a model, so that's encouraging. So I've already clicked in here. I'm just going to hold down Control down arrow to come down to the end here. And look at that. Let's go ahead and expand this out a little bit so we can look at it in more detail. I have coefficients and their exponentiated values just like I did before, but now I also have standard errors. I have p-values. I have lower and upper bounds for the 95% confidence intervals. I've got it performed the calculation to add its own intercept. I've got all of my variables here, and now I can see all kinds of things right off the bat. For instance, here's something quick and easy, even though we're not going to do the interpretation just yet, but if I just want to see, which of my variables have a statistically significant impact on attrition, I can just select all my p-values. I can come to Home, Conditional Formatting, Highlight Cells Rules. I want all the values that are less than 0.05, which is my alpha. Hit OK. Look at that. These are all statistically significant indicators. Age, amount of business travel, the distance from home, technical education field, but notice none of the other education fields are statistically significant. So that's kind of interesting. It makes you wonder why. Environment satisfaction, whether the individual's male, job involvement. So we have a couple here that talk to engagement. That's interesting. And here's job satisfaction, again, another engagement type metric. Whether the individual's single, this log of monthly income worked variable that we talked about, spent some time thinking about in the previous video, and a whole bunch of others. All these, sort of duration in the field or in the workforce or at the company type things, all statistically significant. Very interesting. All right. And then one last thing we can look at. So I'm going to use Control right arrow to come to the end here. Got my coefficients again. Got my covariance matrix. I'm going to use Control right arrow to come to the end of that. And again, we'll talk about this in more detail in the next video. But I have what's called my confusion matrix here, which tells me basically how often I was right about predicting people that were going to leave left and how often I was wrong. And same thing for folks that stayed. and it gives me my total numbers for those, and gives me an accuracy score, reminds me that my cutoff was 0.5, and I've got the data here that undergirds my receiver operating characteristic curve graph. So what I've got right here is a solid model that I can then interpret and use to drive organizational decisions. That is pretty exciting. I appreciate you taking the time to walk through this with me, and I hope you'll join me for the next video where I will interpret all of these coefficients and the ROC curve and the confusion matrix, and we'll talk a little bit about how we can then communicate these somewhat technical numbers to a non-technical audience in a way that they can actually make some use of when they make their decisions. So I look forward to seeing you next time, and happy learning.